Hi everybody, this is picking up where we left off from our lecture on Wednesday, February 3rd, when we were looking at pizzas and robots. And so of course what we're looking at here is a case of increasing opportunity cost between the pizzas and the robots. And what we're really wondering here is how would you then calculate the opportunity cost of a pizza or a robot in this case. So what you're looking for when you're dealing with opportunity cost is pretty obvious on the edges, of course. If you want to make one pizza, you're giving up, or 100,000 pizzas, you're giving up 1,000 robots. If you want to create 4,000 robots, you're giving up 100,000 pizzas. But what is the question of just adding one more, looking on the margins? So if I wanted to create my 8,000th robot in this case, so I would go from 7 to 8. Notice that's not on there. What you have instead is 7 to 9 and 2 to 1. So you would lose 100,000 robots if you gave up 100,000 pizzas if you gave up 2,000 robots. By giving up just 1,000 instead, what you have to look at is the slope, which in this case would be 1 over 2. And so since it would be 1/2 of the original, you would only be giving up 50,000 pizzas instead of the full 100,000. Just like if you wanted to go, for example, from 4 robots up to 5. You're again looking at the slope, which in this case is 1 over 3. So you're giving up 1/3 of the change in 100,000 robots. So in this case, 1/3 of 100,000 would be 33,000. And notice the farther you get up, so going from 4 to 5, you're only giving up 33,000. Going from 7 to 8, you're giving up 50,000. Going from 9 to 10, you're giving up your 100,000, showing increased opportunity cost. If you were to go back the other direction in pizzas and look at how many robots you would be giving up to gain more pizzas, you would see the amount you're giving up is increasing in that case as well. This is the graph of the production possibilities frontier in this case. And what you're looking at here is a case of you have your frontier with points A, B, C, D, and E along it. Anything within it is attainable. Anything along it is attainable, assuming that you have complete, full efficiency of all of your resources. Anything outside of it, as in the case of point W, is unattainable. Productive efficiency is met at any point along the frontier itself. Along the line means you're using all your resources, everything is used perfectly well. That is productive efficiency. But of course, there's the fact that if you're making 10,000 robots and you aren't making any pizzas, people would like to eat. And if you are making 400,000 pizzas but no robot, people still want their robot butlers. And then that brings us into the question of allocative efficiency, which is the best. We realize we can do all of these, but what works best for the overall social good? So in this case, it all depends on what society values. Do they value more robots? Do they value more pizzas? Do they want a point in between? And allocative efficiency is looking at what's best of the productive efficiency points available. I know we talked about assumptions again in class, but I'll just go to those quickly. Assumptions when you're looking at the PPF is you have 2 goods that you're dealing with and no more than 2 goods. You're also assuming that you're in a fixed economy, that there will be no increase in the technology, there will be no increase in the resources. Both of those are fixed. And of course, the third one is that you are using the fourth one is that you're using all of your resources completely efficiently. And so there is no loss, there is no wasted resource, which is why we're able to actually attain the PPF in the first place. Once again, if you're looking at what's happening with opportunity costs, whether they are increasing, constant, or decreasing, it's the shape of the curve. If the curve is bowed out, you're looking at increasing opportunity costs. If it is a linear line, it's constant. If it were to be bowed in, which you're not really going to see, but just in case, that would be decreasing opportunity costs. For a quick look here, this is something that you hopefully got a chance to look at on your own, but this is comparing between capital goods and consumer goods And if you're looking at point D here in the first one, what is the opportunity cost of producing 40 more units of consumer goods? So you want to go from 240 to 280. That shows you going from point D to E. You are giving up 20 capital goods. Looking at point B, what is the opportunity cost of producing one more unit of consumer goods? So you want to go from 100 to 101. You need to find the slope here. So if you went up 80 consumer goods, you would lose 10 capital goods. If you want to simplify that, that goes down to 1 over 8 or 1/8. So by gaining one capital good, you would lose 1/8 of one consumer good. At point C, it asks what is the opportunity cost of producing one more unit of capital goods. So if we look to C, we are at 85. We want to move up to 86. That would be the same because you have your 1/8. For every one capital good you gain, you would give up 8 consumer goods. So you flip the slope from B to C on the other end. So instead of your opportunity cost is 1/8, going from 100 consumer goods to 101 consumer goods in between points B and C. In between points C and B, going from 85 capital goods to 86 capital goods, you're giving up 8. So 1/8 in consumer goods to capital goods, 8 in capital goods to consumer goods. Finally, for 4, for this economy, to produce 100 units of capital goods and 200 units of consumer goods, what must happen? That point is not currently possible. And so what you would need to see is economic growth. Somehow the economy would need to grow from one of the many ways that it can. Whether it is new technology, find new resources. Resources would be the big one. Another source of land, labor, capital, or entrepreneurship could move the entire graph out. If I only found something that helps with consumer goods, only the consumer goods side of the PPF would move out. And of course, this shows the law of increasing opportunity costs in the same way that the pizza and the robots did. Hopefully that helps and made a bit more sense. Have a fantastic day.